Section 8.5a, the Binomial Theorem. In the expansion of x plus y to the n power, x plus y to the n is equal to x to the n times n times x to the n minus 1y plus so on and so forth all the way down to y to the n power. The coefficient of x to the n minus r, y to the r is given by this formula. This is read as n choose r. It's a combination of n factorial over n minus r factorial times r factorial. Shorthand way of writing this combination is right here, and that's the form that we will be writing it in when we are evaluating using the binomial theorem. Now, what you need to use, this is read as n choose r, and it is a combination. That right there gives you the formula for finding any specific term you want to in a binomial expansion, and we'll be talking more about that at the end of the lesson today and even more in the second half of the lesson tomorrow. Okay, evaluate these combinations without using a calculator. So we need to use the formula that we have right here for a combination. N factorial over n minus r factorial, r factorial. So in this case, 8 choose 2, 8 factorial over 8 minus 2 factorial times 2 factorial, which is 8 factorial over 6 factorial, 2 factorial. Use what we learned previously in the chapter. I can write 8 factorial as 8 times 7 times 6 factorial. And once I do that, the 6 factorials are going to cancel. We have 56 divided by 2, which is 28. 10 choose 3. 10 factorial. 10 minus 3 factorial times 3 factorial. So when I go to rewrite that, 10 times 9 times 8 times 7 factorial over 7 factorial times 3 times 2 times 1, which is what 3 factorial is. 7 factorial cancels. 3 goes into 9 3 times. 2 goes into 8 4 times. 3 times 4 is 12 times 10 is 120. Seven choose 0. 7 factorial over 7 factorial, 0 factorial. And these combinations also have a lot to do with probability. What a combination is it means 7 things. Whatever you are choosing from is how many things you are choosing, and then in groups of whatever. So if I have 8 things and I want to choose them in groups of 2, how many different ways can I do that? 28 different ways. If I have a group of 10 things and I want to choose groups of 3, how many different groups of 3 can I pick from 10 things? 120. If we think about this third one, 7 choose 0. If I have 7 things laying down and I want to choose none of them, how many different ways can I do that? 1. Not pick any of them. That's the only way it can be done. 7 factorials cancel. We're left with 1 over 1 there. Here, 8 choose 8. 8 factorial over 8 minus 8 factorial times 8 factorial. Once again, if we think intuitively about this, 8 things to choose from, and I want to choose all 8 of them, how many different ways can I do that? Only 1. Again, 8 factorials cancel. We're left with 1 over 1. There's only one way that can be done. Evaluating combinations with calculators. So let's go to the calculator. We'll plug each one of these in and then record the answers. Oops. So go to the calculator here. Combination is underneath math and probability. First one, 7 choose 3. Put in what you are choosing from. 7, math, probability. Third command down is combinations. 7, choose 3. 35 different ways that we can pick 3 things from a group of 7. Next one, 7, choose 4. 7, math, probability, combination, 7, choose 4 is also 35. 12, choose 1. Without going to the calculator, if you have 12 things and you want to choose only one of them, how many different ways can that be done? Should make sense intuitively that 12, choose 1 would equal 12 different ways that we can do it. And finally, 12, choose 11. 12, choose 11 is also 12. So going back here, recording those answers that we just got from the calculator. This one here is 35. This one here is 35. And each of these were both 12. Notice the pattern that you see here. 7, choose 3 is the same as 7, choose 4. 12, choose 1 is the same as 12, choose 11. Remember, 7, choose 3, if we did this by hand, is 7 factorial over 4 factorial, 3 factorial. 7, choose 4 is 7 factorial over 3 factorial, 4 factorial, so you can see why those are going to be the same solution. Same thing for 12, choose 1 and 12, choose 11, why those would be the same solution. Another way besides calculator and doing them out by hand to evaluate combinations is by Pascal's triangle. Here is Pascal's triangle. We start with a 1 up at the top, a 1 in row 2, and then from there we can derive the rest of the triangle from knowing the row above it. This 3 right here is obtained by the 1 and the 2. This 10 right here is obtained by the 4 and the 6. This 5 is obtained by the 1 and the 4, and so on. So if we wanted to go down and write another row, we would start with 1. Then in between here, we would have 8 because 1 plus 7 is 8. 7 plus 21 is 28. 21 plus 35 is 56. 35 plus 35 is 70. 35 plus 21 is 56. 21 plus 7 is 28. 7 plus 1 is 8. And we have 1. We could keep going for as many rows as we wanted to. Now, when you're talking about Pascal's triangle, we start with row 0. And we go from there. Each entry within a row, we also start by calling that 0. Okay, and what we can do then is evaluate combinations this same way. Notice over here we had, on the last slide, we had 7, choose 3 is equal to 35. If we look at row 7, row 1, 2, 3, 4, 5, 6, 7, there's row 7, and we want to choose 3. Sorry, this is row 7. That was row 6. So this is 7, choose 0, 7, choose 1, 7, choose 2, 7, choose 3, and 7, choose 4 were both 35. So from Pascal's triangle, we can obtain combinations. Pascal's triangle is also going to be used for multiplying out binomials. If it is a binomial, that is a sum, meaning x plus y, then all your signs going across will be addition. And this is just a way of checking to make sure your answer makes sense at the end. If it is a difference in our binomial, x minus y to the n power, your signs should alternate from positive to negative. So it's a quick check at the end to make sure that you're not making some sign errors as you are evaluating a binomial expansion. Evaluate these using Pascal's triangle. 6, choose 4. So we're going to go back to the triangle. Need to go to row 6. 0, 1, 2, 3, 4, 5. There's row 6. We have 6, choose 4. This is 6, choose 0. 6, choose 1. 6, choose 2. 6, choose 3. 6, choose 4 then has to be equal to 15. 5, choose 2. Go back to the triangle. Row 0, 1, 2, 3, 4, 5. 5 choose 0, 5 choose 1, 5 choose 2 is equal to 10. Okay, in our expansions now. X plus y raised to the 4th power. You have to look at each term separately. Okay, so we're looking at the x term, we are looking at the y term. When we go to begin writing out this expansion, the coefficient is always a combination, starting with choosing 0. The top number is always what we are expanding to. So we have 4 choose 0. First term to that highest exponent, second term to the smallest exponent. So 4 choose 0, x to the 4th, y to the 0. Plus our next term, move up 1. So 4 choose 1. Our first term goes down an exponent. Our second term goes up an exponent. 4 choose 2. First term goes down an exponent. Second term goes up an exponent. 4 choose 3. First term goes down an exponent. Second term goes up an exponent. 4 choose 4. First term goes down an exponent. Last term goes up an exponent. From here now, each one of these are combinations. 4 choose 0, 4 choose 1, all the way up through 4. So begin evaluating here. 4 choose 0. You can get it from Pascal's Triangle, or you can plug it into your calculator. We get 1, x to the 4th, y to the 0. 4 choose 1 is 4. X cubed y. 4 choose 2. 6, x squared, y squared. 4 choose 3 is 4, xy cubed. 4 choose 4 is 1, x to the 0, y to the 4th. Finish simplifying here, we just end up with x to the 4th plus 4, x cubed y plus 6, x squared, y squared plus 4, xy cubed plus y to the 4th. There is our expansion of x plus y raised to the 4th power. Notice that in your final answer, every x exponent is decreasing by 1 each term. Every y is increasing by 1 each term, and that should be your pattern always when you are expanding these. Third one, 2x minus 3 cubed. Start with your binomial. Highest possible exponent, choosing 0. 3 choose 0. First term to the highest possible, last term to the lowest possible. 3 choose 1. First term decreases by 1. Second term increases by 1. 3 choose 2. First term decreases by 1. Second term increases by 1. 3 choose 3. 2x to the 0. Negative 3 cubed. Begin simplifying. Again, you could go to row 3 in Pascal's Triangle and very quickly get each one of these combinations, or you can go to the calculator. 3 choose 0 is 1. 2x cubed. 8x cubed, negative 3 to the 0 power is just 1. 3 choose 1 is 3. 2x raised to the second is 4x squared times negative 3. 3 choose 2 is 3 times 2x. Negative 3 squared is 9. 3 choose 3 is 1. Anything to the 0 power is 1. And negative 3 cubed is negative 27. Continue simplifying. We get 8x cubed plus, multiply all this out, we get negative 9 times 4 is negative 36x squared plus 54x minus 27 Notice that our signs here are alternating. Remember, we talked about in a binomial, when it is a difference, that your signs should end up alternating at the end. Last one, x minus 2y to the 5th power. First combination, start with the highest possible exponent. 5 choose 0 times x to the 5th, negative 2y to the 0. 5 choose 1 times x to the 4th, negative 2y to the 1st. 5 choose 2, x cubed, negative 2y squared. 5 choose 3, x squared, negative 2y cubed. 5 choose 4, x, negative 2y to the 4th. And finally, the last term is going to be 5 choose 5, x to the 0, negative 2y to the 5th. Begin simplifying all this. 5 choose 0 is 1. X to the 5th times 1. So we have 1 times x to the 5th times 1 plus 5 x to the 4th times negative 2y plus 5 choose 2 is 10. X cubed, 4y squared. 5 choose 3 is 10. X squared, negative 8 y cubed plus 5 times x times negative or positive 16 y to the 4th. And our last term right here is 1 times 1 times negative 32y to the 5th. Go through and clean up each one of these. Finish simplifying. We have x to the 5th minus 10 x to the 4th y plus 40 x cubed y squared minus 80 x squared y cubed plus 80 xy to the 4th minus 32y to the 5th. There's our final expansion of that binomial.